Hello everyone, I'm UT and I built Umbra. What is Umbra? Umbra is a secure CEE powered transaction router designed for autonomous AI agents and institutional trading desks. What we're building is a way to bridge the gap between autonomous on-chain execution and strict compliance safety. It allows agents and humans to route trades privately through a Terminal 3 enclave, keeping transaction intent completely shielded until execution. Let's imagine a scenario where a trading desk running an autonomous agent that needs to rebalance its treasury by swapping USDC for wrap ETH. If the agent broadcasts its trade intent directly to the public mempool, MEV bots will immediately detect it and front-run the trade, costing the firm money. At the same time, compliance require absolute verification that the agent only executed the exact pre-committed route with zero out-of-bound leaks. Here's how Umbra comes in to solve this. Before running any trades, the agent or the operator queries the orchestrator. We start by checking the health of our system. This returns the active dark pool status and the exact cryptographic measurement, the MR enclave, of the code running inside our TEE. We can also check the deposit credits for a trading wallet using the CLI or the UI. On the UI, we can see our current deposit credit here and our wallet balance. We can also use the UI, the PMPM Umbra credit command. And we see we currently have 1.7 USDC tallying with our UI. To execute trades, the desk first deposits collateral into the pool. Since this wallet has already interacted with our pool in prior sessions, we already have an active credited balance of USDC ready. You can see our existing pool credit is visible here in the stats panel. But if we were starting afresh, depositing is as simple as clicking deposit right here in the dashboard. So this works with approvals. If we go above the existing approval, we need to approve again. So let's just deposit. Okay. This credit model is key. Swap output wrap ether is routed directly to our trader wallet, keeping the agent's operating capital clean and isolated from the pool's share assets. Now let's submit our trade intent. We'll select the private TEE routing mode. This ensures our trade runs shielded through the enclave. Let's start the swap. Say 0.5. That was done as quick as that. Behind the scenes, the Umbra orchestrator commits the intent inside the TEE, locks in a Uniswap quote, signs the transaction via a delegation credential, and settles it on base Epolia. The intent itself was never exposed to the public mempool, shielding us from front-running risk. And as you can see on our activity tab, the swap has been recorded. But what happens if a compromised agent or bad actor tries to bypass the security boundary and route the transaction insecurely through the public mempool? Let's test this by toggling our routing path to the public mempool and attempting the swap again. The enclave policy blocks it immediately. Notice the block message. It tells exactly why the swap was stopped. Because broadcasting the intent publicly violates the security policy to protect against MEV front running. This rejection is recorded as a compliance audit log, proving that the agent is strictly bound by the enclave's safety policies. And that is Umbra. It's an institutional-grade router combining Terminal 3's TEE commitment, delegation credentials, and secure execution on basic polio. It gives agents the privacy they need to trade safely, while giving compliance teams the cryptographic audits they require. Thanks for watching.